Gmail, Facebook, Snapchat, Twitter, and the majority of mobile games all share one thing in common. In some way, they all require an internet connection to get data from a server. Even a simple weather app gets its information from the web. In the most general sense, to have an app that connects to the internet, you're going to need two things: a client app and a web server. In the case of this weather app, the Android app is the client app. The server would be some server out on the internet with up-to-date weather information. OpenWeatherMap.org is an example of such a weather server. Engineers who work on servers are known as back-end engineers. They work with different technologies than, say, you as an Android developer. This is because you're working on the code here on the client app. As the person coding the client app, you need to decide how to sync data on the client app with the data on the server. Now, you might have worked with a weather app known as Sunshine, which we used in an earlier course. Sunshine used a data syncing strategy known as polling. Polling, when we're talking about client-server communication, is the act of continually pinging the server every so often to see if there are any updates. If you've seen apps using job schedulers or sync adapters to connect to a server, more likely than not, the app is using the polling strategy. For example, in Sunshine, a job scheduler was used to sync with the server every 3 hours. Now, for a server like OpenWeatherMap.org, the weather server that I mentioned before, this strategy might be acceptable. Perhaps we know that the weather updates every day on the server at midnight UTC. But let's take a moment to think about Squawker. Our course developers are free-thinking and not trapped by the constraints of a schedule. They can send squawks at any time of the day, whenever the mood strikes them to share. So, if you have a server like this that's not updating at a regular time, how would you use a job scheduler and polling to make sure that users get their squawks in close to real time? Well, you could have your app poll, say, every 30 seconds or so to see whether there's any new squawks on the server. This, though, turns out to be incredibly battery inefficient. That's because the course instructors are pretty busy people, so even though they have rich social media lives, they don't post something every 30 seconds. Now this means that most of the time, you're going to be uselessly pinging that server. Making this network connection will drain the battery, and it will be doing so for a usually useless network ping. Using the wireless radio actually turns out to be one of the most battery-draining things that you could do on an Android device. Every time the wireless radio is used, your device needs to power up the radio, which is especially costly. It is much better to do a bunch of network activity all at once and then let the radio power down than to be continuously powering up the radio every 30 seconds. So another option would be to check less often than 30 seconds, say every hour. But if you only check the server every hour for new squawks, then you will only get new messages every hour and not in real time. Remember, we want our users to get squawks within milliseconds of them being sent from the server, and not an hour late. Neither the option of polling every 30 seconds or polling every hour seems really that great. And this is why many apps that need data in real time use what's known as pushing instead of polling. The idea behind a pushing strategy is that instead of having your client phone constantly asking the server if there are updates, instead, the server is responsible for telling the phone when it has new information. The server can decide what information to send down in the message. Once the client app receives the message, it's up to the client app how it will respond. You could have the client app react however you want. For example, with Squawker, when the server sends a message that the server has a new squawk, it could trigger the code to save a single squawk, re-download all the data from the server, trigger an entire database sync, or have the phone make a loud squawking noise, or really anything else like you'd like. Pushing as an update strategy is always more battery efficient than polling. The cost is that you need to change both the code on the server and the phone. To implement this yourself, this requires you to control the server or, have a friend that has the skills to write server-side code. In this lesson, I am that friend. I've written the server-side code for you so that you can focus on learning how to implement the client side of pushing to Squawker. Before we dive into the code, let's do a quick quiz.